So hi everybody. In this video / live stream, I'm going to show you one of my projects that I have done for my students. It's called contact tracing with Elasticsearch. And as you know, this is a live stream recording. So everybody who's watching the live stream, put in the comments, let me know what you think. So here's what I have done to do a quick setup that you understand what this is all about. So what this is all about is that I created a project. I was thinking throughout the last 2 years, we heard a lot about contact tracing and basically following infection or infected people around and trying to find out who is infecting whom. So in this fun project, I was actually trying to do this with Elasticsearch. You could create a big database and model everything. And I was thinking like, okay, could I do this even simpler? Could I do this just by putting Elasticsearch up and using it like a search engine and displaying that? So that's what I've done here. How I set this up is I got myself a public data set from San Francisco. This is a data set that they have on their public data set site. And you can download this. Then I created 100,000 fake users. With the Faker library. Faker library is really a cool library for testing and also for setting up demos where you need users but you don't have users. It creates device ID, name, address. It can also create birth dates and so on and so on. So really cool. So 10,000 businesses I selected from the San Francisco dataset. With these 100,000 users, 10,000 businesses, I made scans whenever somebody entered a business. And this way I basically did 1 million random apps for 3 days. I could also do this for just 1 day. I think it would even be more interesting for 1 day. But yeah, that's the setup on this. And quickly do something here. So looks like an interesting project. Yeah, that's what I thought as well, and that's why I did this. So this 1 million random app scans I packaged into a Parquet file, and then this Parquet file I put into Elasticsearch, just uploaded it as a bulk import and created a Streamlit app for this. And that's what you see here in this next screen on the website. Basically, I have this set up here on my computer. I have Elasticsearch running in Docker. It's a small instance. I made this for only that it works only with 4 GB of RAM. So it's a very small instance. And the Streamlit app that I created basically looks like this here. So everything the app does, can I move this somewhere else here? Everything that the app does is it gives you the option of creating a free text search where you put in something and it's going to find you the business for this. You can search by zip code. That's what I have here in this first view. You can also search them by business ID and device ID. And with the device ID, that's actually the user that you can track. Now, as I said, we could have built a relational database for this, but I actually didn't want to. I was wondering, okay, I have this information. Let's just feed this in here. And so I created here a link, for instance, for the San Francisco website where we have our zip code maps, and now you can just select a zip code here. Let's say this one here, 122, and then you put this in, and this then shows you all the businesses in here. It's that quick. And you can, how I did this is you can hover over it or click on it, then you have the name of the business and you have the ID, so you can actually even see this if you just click around here. And I made this that this has a table where you can go around and you can search through this and see what's all in here. It shows the business ID, the name of the business, the address, and the zip code for this. As I said, we could also go here and say, I want to search for burger. Then you put in here burger, and then it's going to show you all the burger places. So there are not many places here with burgers. I didn't try this. Auto, if you put in auto, it will show you auto dynamic, auto sales, discount auto performance. You see, so that's how easy this is. Is this cool or what? I mean, I find this very interesting and very quick. It's only 200, it's a million data points. It's only 250 megabytes of data, but it works on a computer with 4 gigabytes of RAM. I mean, it's amazing. With that, what you could do is you could say, okay, auto, let's go to discount auto performance here. Let's say, let's take the business ID from this and let's copy this and put it into the business ID here. Boom. Then we scroll down. Then we have everyone who actually visited. Can I make this even bigger? Let me try to make this even bigger so you see it better. Then you see who actually visited this auto store. Or this auto, how was it called? Auto discount auto performance. So once you have this, you could now see who was in here, and I sorted this by time. So you can see on the 2nd of January who was there at 8 p.m. 8:32 was Brian here, and at 8:49 was Brandon. Who was there. And now you can say, okay, let's follow Brian around. Let's take Brian's device ID and let's search where Brian went. So then you can see here, Brian, okay, everywhere Brian went to 16th Avenue Apartments. That's, I'm guessing, does that fit? Yeah, that fits, right? Discount order performance, premier order detailing. Where's that? Discount order performance, 1900 Mission Street. So we have to find this here, 1900 Mission Street here. Yeah. So that's how this then looks, and then you can see, okay. That's where he went. Discount order performance here. Mission Street, 15th. Yeah, so let me know in the comments. How did you like this? What do you think of this? Is this an interesting project? When I created this, I was thinking like, how can you solve this? It's really interesting because you can now see, okay, he was here at discount order performance. Let's see Esquire Reality where he was before. Then you could take the business ID here, put the business ID in there, and then you see business who was here at this business and when. Yeah. So that's what this was. The problem with this, or the most complicated thing in this, was actually creating the data set for this. And yeah, that's how I basically created this data. I got the San Francisco open data set. I used the data set from here. I used the Faker library to create these users. And then I used pandas actually here to create data frames for this, create data frames for this. Then I merged this, packaged this into Parquet file, uploaded this into Elasticsearch and Streamlit. Now this is not, of course, not optimized. The thing is with Elasticsearch, it's just a search engine. So you could actually do something where you say a graph database, for instance, would be very interesting here to use. So that might be something to look for, to change, instead of using Elasticsearch as a backend for this. Create create something different. What should I search for? Let's see. Anybody? Let's use the free text search. What should we search for here? The cool thing with this is I used folio maps for this. These are not the standard Streamlit apps, so the folio maps are really nice because they have street layout. They show actually the buildings and so on. That's where I really like them. They show parks. Apple Store, very good. Let's just store Apple. No, it's actually no Apple Store in this. But yeah, okay. It's because I took 10,000 of the 140,000 businesses. So most likely, well, no Apple Store. The thing is, when you search here, the free text search, Elasticsearch is going to match everything. So when you put in 2 words, it's going to match everything that has one of these words into that. So yeah, unfortunately, Apple isn't in here. CSV Consulting, CSV Hospital Management LLC are the ones in here. CSV Consulting, CVS. I'm sorry, CVS. CVS Associates Pharmacy. Tommy. Van Ness Avenue. I don't have that. Maybe. Van Ness Avenue. Tommy's Joint. Hardin Anchors. Which one was it? This, filter this, go here for anchors. Hearts and Anchors. Yeah. So then this way you can go here, can see who was there. These users, Benjamin was here. Diana Porter, and then you can follow people around. You can, okay, let's put Diana here. Where did Diana go? Here. Yeah, so really nice. I like this. Yeah, and that's all I wanted to show you today. This is, and I just want to stress this. This is without any modeling of a database or something. It's just everything is in a JSON string. So whenever somebody makes a scan at a business, then you get basically this information here: username, device, scan timestamp, business ID, business name, business address, city, zip, longitude and latitude. And with that information, we just drop this into Elasticsearch and then search through the index and find this out. And the only thing I do then is put this on the user interface. Yeah, and it's, yeah, I like this. I said there are better ways to do this. If you do something like a graph database or something, yeah, that's a lot better, I'm guessing. All right. So much for a quick live stream. I hope you like this. Let me know in the comments if you like this. If you want, I can stay here for 5 more minutes so we can do a Q&A. Let me know any question that you have in the comments. Yeah, I'm always trying to create stuff for that makes sense, that is fun. Of course, it's hard to package everything with with fun. Yeah. You're welcome. By the way, yeah, I already forgot. I should do this all the time. So if you're interested in data engineering, check out my Data Engineering Academy, where I teach data engineering from basics, platform pipeline design, fundamentals, fundamental tools like Fast API, Spark, Kafka, MongoDB, data warehouse, and so on, to example projects like the one you just saw. This one here, we have an associate data engineer certification, and machine learning project, AWS, Azure, document streaming, as I said, with Kafka, Spark, and so on. Yeah, check this out if you're interested. If you have questions, let me know in the comments, send me a DM, and then, yeah, see you later. Bye.